familiar with the structural insulated panel. Now we're beyond structural insulated panel. We improve structural insulated panels using a combination of native, material that is local to wherever. As you've seen the palm trees, and it's also recycled or recyclable materials. And so we try to be as low cost as possible by getting stuff locally, and also as much as possible recycled materials. So we'll combine three proven technologies together with eco-friendly materials. So this is structural insulated panel. That's one. I'll go into detail after. A structural insulated panel is one that is currently used mostly in the United States to build houses. Steel stack construction, replacing a lump of timber by steel trusses, and also airline technology, which is known as the stress skin, which is how jets are built. Basically, the outer layer of the skin acts as a structural element, and this is mostly for making roofs. So structural insulated panel, you know the Oreo cookies? Mm-hmm. Okay, so basically Oreo cookies got two rigid parts on each side and a mushy part in the middle. So the mushy part is the insulating material, whereas the structural, what provides the strength and structure are the two rigid panels. So in the United States, they like lumber, use a lot of wood, so they basically use plywood or what I call oriented strand board, which is a chip wafer boards, or but these panels can be replaced by panels made of cement or cementitious materials, more rigid, that are especially in climates like here, where you got moisture and insects and this and that. We try to avoid wood as much as possible. So here we would use cement material. Right now we're experimenting various recipes. We would combine soil, earth, clay or lime and cement, different combinations. We try to find the perfect recipe for enough rigidity while being still certain flexibility. So basically what they do is they assemble, they put a post and they slide each panel, which is like a typical 4x8, big plywood sheet or typically 4x8, so floor to ceiling, and in between the mushy part is a polystyrene or urethane. So this is not very ecological, all chemical products, petroleum derived products. So we're trying to go differently when it comes to what we put inside. So there's quite a bit of versatility. So you can put the panels and cut them in any shapes beforehand. So when you come on location, everything is ready. So everything is numbered, so you can set up a house in a day, or a day and a half, basically, at least the shell. And they would provide a finishing, whether either fake bricks or cladding or anything. Same for the inside. But what we do want to be even faster here is that because we use cement-based material, we have the finishing for the outside already. We don't have to add it afterwards. Each panel will come ready. So here's an example of something that is currently being built right here by the beach. They used recycled styrofoam. For the packaging, the white stuff. They basically shred it into small little bits, and they mix it with cement. And they bring some tests. So you can see that the white stuff is styrofoam, and this is a 8-to-1 ratio, so 8 times more styrofoam than cement. And cement is really just to bind the stuff together. It's still quite rigid. It's quite stronger than, let's say, compressed styrofoam. It's quite rigid. In this particular case, they really packed it on site. They put the formworks, and it took about a day to do a little panel, because they do it manually with a little whoosh, and whoosh. So it took about a day to raise it up to 3 meters. So obviously you want to do much faster. So basically each of the modules, the panels, would be prefabricated in a small factory. So these are the modules, the way they would look. Basically you got the rigid part, two rigid parts, and in between we put a mixture of shredded styrofoam, and we will reduce the amount of cement by using earth concrete, which basically it's mostly 5 parts sand, 3 parts soil, and 2 parts cement. So very little cement, about 20% cement content, just to bind the, and then that cement is only 1 out of 10, and we're going to reduce it to 10-to-1 ratio. So very little cement, just enough to hold it, and give it enough rigidity, and we can mold it all at the same time, put the rigid part flat, and then as the cement is still fresh, we put the second layer with mixture, and then finish it up with the rigid layer. And we put metal studs on this side, on one particular side, so it's really tongue and groove. So as we put it, we push it into the next one. We put a little mortar, push it, poof, so that all panels are joined one after the next. So we don't have to put a separate stud and then join them, just push them in. We've got a guide track on the ground, on the floor, a U-shaped metal piece, just slide them, put a little more, push them, and doing that so we can put a wall in very little time. And this is the stressed skin roof. Basically we use corrugated steel roof, but typically the ridges would be downwards, would go this way, but by simply twisting them 90 degrees, it becomes a stressed skin because the steel itself takes the load of the stress of the torsion. So we eliminate all the reapers in between the rafters, and we also eliminate all those parts here. It's really just this, like this.
There's no truss work.
No truss work.
You see clean finish below if you do a second fall ceiling here. You can have a clean roof without any truss work.
And then just it's all taken by the torsion and everything is taken by the metal
skin.
So you would still see the underside of the aluminium?
You could see it, or you could choose not to see it. You put a second layer here. You could have a false ceiling.
And also for this we want to do something fancy for some of the models. We use what we call a green roof. Basically we grow grass or whatever, which would provide insulation. Like a steel, of course, still no insulation. So by putting a layer of sod or plants, and the fact that we would have a little sprinkler system, it creates its own little zone of, it's like a perspiration, it cools off. So it creates a layer of insulation so that the roof where all the sunlight hits is cool. So very economical.
So you could do that with corrugation as well?
This
turn at 90 degrees?
We've just put it at 90. There's some limitation for the angle. This is about the variance is about I think 23. Yeah, the slope is 23 to less.
15.
Yeah, 15 to 20. Yeah. So, and also it could be like a sort of like an arch, like this. The structure could be made into. So it's either rounded or about this angle, typically for steeper angle. It's not good for this. It's too much stress on that.
The steeper the better actually, because we're doing a green roof. We cannot do a steep angle. So then everything drains off. The soil washes off and all that.
How does the sod adhere? Is it just the corrugation that it clings to? I mean, if you have heavy downpours,
it should come off, So that's why we thought we shouldn't put just soil out there. We said we should try and find a material which will hold the soil together. And we found, again, we went to the waste shop, the landfill. So we found that a whole lot of mattresses go to the landfill. Mattresses have no recycling value actually. And in India it's not spring mattresses, it's always sponge and coir. So it's about typical mattresses are 4 inches thick. You speak in inches or centimeters? Okay, so 10 centimeters thick, and 2.5 centimeters of sponge, 7.5 of coir. It's like a coir bed on top of sponge. It's perfect for a green roof.
Because the coconut fiber is good material for roots to grow into. So whatever plants would actually cling to the coconut underneath, provide good material for like compost basically. Those mattresses or
Yeah,
compost. And
yeah.
you used to lay down. It's really just flat. They're all pretty much the same size, about 2 meters long. And just flat them. Boom, 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 boom.
And you don't have to adhere them to the roof?
Yes, we'll
Yeah.
have to. We'll have to tie the tops across, we'll have to tie it with wire,
Yeah.
so it stays on the roof. And
Things like that.
yes, it's green roof is a green roof. It will have insects, it will have all kinds of things on it. But the fact is that below it is a solid steel structure, so all that does not need to come in.
Yeah.
And if the windows are like this, and the ventilators are with mesh, then all the bugs that are on the roof will not enter the house.